Hello and welcome everybody. My name is Dana Yanch and I'm a senior systems engineer with Aviatrix. Since joining Aviatrix, I've had the opportunity to speak with cloud network architects from all around the world. Cloud network architects that are in every single vertical, managing cloud networks of all shapes and sizes. And the one common thing that I've noticed is that all cloud network architects eventually have to deal with the challenge of picking the right transit solution for their cloud network. Transit architectures in the cloud is the most important component of cloud networking you will ever have to deal with. It's the heart of your network. It's what brings everything together. So today, instead of being a systems engineer, I'm going to step into the shoes of a cloud network architect and walk you through the common requirements and decision-making process that you'll go through when picking a transit solution for your cloud network. So let's get started. First things first, let's walk through common requirements that I usually see in the real world that will help us determine the proper transit solution. Number one, organizations might be starting small. They might be starting in a single cloud, but there should always be an expectation that they're going to expand, whether it's to multi-region or eventually to multi-cloud. So we need to ensure that manageability works at scale, that we can handle large-scale cloud networks, no matter what business requirements or technical requirements come down the pipeline. Number two, security teams mandate high performance end-to-end encryption. Number three, security mandates segmentation in the cloud. We've had segmentation on-prem. We need to carry the segmentation into the cloud. Number four, security mandates that we insert services like next generation firewalls for traffic inspection in the cloud for east-west, north-south, and internet egress. Number five, we need to make sure we can meet advanced networking requirements like NAT for partner connectivity or traffic engineering for more complex intra-cloud and inter-cloud and cloud to on-prem connectivity models. Number six, we need to ensure we have visibility and troubleshooting tools at our disposal. We can't go into the cloud blind. We're moving production workloads, the workloads that make our company's money, into the cloud. So we have to ensure that we can guarantee uptime, guarantee visibility and reporting and chargeback, and the tools that we're used to having on-prem now in the cloud, so we can troubleshoot problems and resolve them very quickly and efficiently. Number seven, this whole transit architecture needs to be simple, needs to be repeatable, and there has to be governance. Lastly, we need to ensure that our investment is secured across any cloud. We might start in Azure, but we may need to then dabble in AWS, or we might go head first into AWS, or maybe there's a massive shift to a completely different cloud. You need to ensure that all the investment you made in one cloud is repeatable in another cloud. Let's start with manageability at scale. You can see that I already have my whiteboard set up. On the left are the basic CSP transit functionalities. On the right are the Aviatrix advanced enterprise functionalities. First of all, basic CSPs definitely scale. They've been designed to scale for sure. However, they scale with limitations, meaning there are route scale limitations. You have only a certain amount of BGP and static routes that you can insert and configure on these basic CSP transit environments. And they're pretty low numbers from the perspective of scale. Number two, these CSPs limit where you can instantiate these transit constructs, in which regions support them, how many you can instantiate, and how they can even connect to each other. Some CSPs don't even allow you to connect transits within the same region to each other. Very important things to consider here. Once you've spun up these transits in the CSP, you now have to configure them completely manually. Construct by construct approach. It's up to you to log into the console, configure every construct, every route table, every route entry manually. There's zero network correctness intelligence. What I mean by this is there's nothing built in to these transit environments to stop you from shooting yourself in the foot, from making mistakes, from causing overlapping CIDR issues, from causing route loops or suboptimal routing. There's nothing in there auditing what you're doing. There's also no route control when you're leveraging these CSP transits. What I mean by this is if you're connecting to a partner or a third-party entity or just some network where you don't have control over the BGP routes that you're learning, they could send you anything. They could send you a default route, they could send you a more specific route, an overlapping CIDR, and all of these things can totally mess up your routing infrastructure in the cloud. You need to be able to control that and filter those routes as they are learned in the cloud. You also have a completely different control plane, data plane, and management plane per CSP. So you figure out how to do things in one cloud, you now have to figure it out all over again in another cloud. Okay, let's see what happens when you leverage Aviatrix as your cloud transit. Number one, Aviatrix has been proven to scale to extremely large environments without limitations. We don't have those same route scale concerns. We can support tens of thousands, if not 100,000 plus routes on our gateways. You don't have any of these regional limitations. They've all been lifted. Wherever you can instantiate a compute resource, you can instantiate Aviatrix transits. So that means you can put a transit in any region, in any cloud, anywhere around the world, and not have to worry about how they connect to each other or if they can connect to each other in the first place. Since Aviatrix is a controller-based model, it's intelligent. And so the controller can program everything for you end to end. I'm talking about route tables, security groups, NACLs, TGWs, attachments, gateways, load balancers, pretty much anything networking construct related. Our controller understands how to program them for you in the best practice way. So it's an intelligent controller based approach to cloud networking. And because it's intelligent, you get full network correctness. And so our controller will ensure that you don't create a loop unintentionally, that you don't cause an overlapping CIDR environment, that your route tables end to end are populated correctly so that your traffic can flow seamlessly within the cloud or across clouds. You also have full route control now because the controller is watching all the routes being learned in the cloud and from on-prem. You can then apply safeguards where you have to approve the routes being learned before they are populated or programmed anywhere else in the network. Lastly, you now have a unified control and management plane. You have that controller, that centralized brain that acts as the unified control and management point across all your clouds. On top of that, we normalize the data plane. You leverage the Aviatrix data plane alongside the native data plane to build this normalized end-to-end data plane that's simplified and that abstracts all the complexities under the covers. So who wins this one? Yeah, you got it. Aviatrix wins this one. Pretty straightforward. When it comes to manageability at scale, who wins this battle? 100% is Aviatrix. No argument. Let's move on to high performance end-to-end encryption. And I'm sure you've heard this before. More and more companies are mandating that all the data in flight must be encrypted no matter where it is. So it's just as relevant to the cloud as it is anywhere else in networking. So let's take a look at what basic CSP transits offer. They offer very limited encryption with no end user control. What I mean by this is that not all paths, and actually a limited amount of paths within the CSP transits are encrypted to begin with. Anything that is encrypted provides no end user control. You have no control over the algorithms or any visibility into the algorithms being used under the covers. This is a big problem for most security conscious organizations. When you terminate your own VPN connections in the cloud, you end up lowering your performance massively. Basic CSP transit constructs support very low performance VPN termination. I'm talking about 1.25 gig per tunnel. Where we are today, that's pretty low. Lastly, encryption, if any exists in the first place, ends at the CSP edge. You then have to leverage your own mechanism to encrypt, to go back down to on-prem, or to encrypt to go to another cloud or to another region, whatever it might be. It's up to you. Let's look at Aviatrix. In the Aviatrix platform, all packets in flight are encrypted at near line rate, end to end. It doesn't matter if you're coming from on-prem into Aviatrix or if you're going from transit to transit or spoke to spoke or cloud to cloud. It's all encrypted and you have control over the algorithms. You have control over the visibility of what's being leveraged for all these encrypted tunnels, statistics. You have access to all of that. We can even encrypt to on-prem over ExpressRoute and Direct Connect and retain that 10 gig plus line rate throughput. Pretty incredible. Within the cloud, we can support up to 75 gigabits per second of encrypted throughput. Unparalleled, unheard of before. Our encryption architecture is unlike none other. As mentioned before, Aviatrix encrypts multi-region as well as multi-cloud. So wherever you've built that Aviatrix data plane, a full mesh of encrypted tunnels will be built. You never have to worry about encryption ever again. So who wins this one? You got it. Aviatrix does. Let's move on to segmentation, another key topic in networking today. We've been using segmentation on-prem for years. We've been using segmentation in wide area networks for years. We need to retain segmentation as we move into the cloud. We can't just throw away these security requirements as we move into cloud. They need to be retained. We need to leverage the same functionalities that we had in the past. So what do basic CSP transits offer from a segmentation perspective? Basic segmentation, if any at all. Really, there's only one or two CSPs that offer any type of segmentation from a routing perspective. Everything else is very manual from a access controlless perspective using security groups or NSGs. Very, very complex to manage, not flexible, not scalable. As I mentioned before, handling the manual configuration of routing or route tables to configure pseudo segmentation or configuring NSGs or security groups manually is very complex, does not scale. It's a huge pain. If you're even successful building some measure of segmentation leveraging basic CSP transits, you're going to lack on visibility around the segmentation and its connectivity model. You're not going to know who's able to talk to who in any easy way. It's going to take a lot of digging to figure that out. In addition to that, segmentation ends at the CSP edge. Once you need to move into on-prem or to another CSP, all that segmentation you've built in one CSP doesn't carry anywhere else. Let's look at Aviatrix. Aviatrix can support advanced scalable segmentation. We've been working on this for a long time. We have a lot of customers leveraging segmentation. And in 6.0, our latest release, we now support even more advanced segmentation I'll go into here in a moment. Aviatrix leverages an automated policy-based segmentation model with controller intelligence. The controller understands policy and where to enforce segmentation based on the architecture that you set forth in your configuration. And the gateways will ensure that segmentation occurs in the correct and strategic places across the network. On top of that, once you've configured the segmentation, you can go back and leverage visibility tools and the UI to figure out who can talk to who based on your policy. So really easy to figure out the connectivity model around segmentation after you've deployed it all. You can segment anything, anywhere. Segment awareness is carried globally across clouds, and this is a new feature for 6.0. We're able to take your segmentation model in AWS and apply it the exact same way in Azure, GCP, OCI, etc. Because you're leveraging Aviatrix to handle segmentation, Aviatrix is agnostic to the cloud it's running on. So you can carry that same policy model for segmentation anywhere. You can even segment traffic coming in from on-prem, or segment traffic coming in from partners, or segment traffic coming in from an sd-wan environment. Really, the sky is the limit here. So who wins this one? Again, another straightforward win. Aviatrix for sure. All right, here's a cool one. Service insertion for next generation firewalls. I love this topic. Let's jump right into it. Basic CSP transits, they offer the service insertion of most next generation firewalls. Sure, you can jump into the marketplaces and spin up a Fortinet, a Palo Alto, a Cisco, Checkpoint, whatever you want. That's great. However, you have a limited scale for that next generation firewall insertion. What I mean by that is, depending on the architecture you're going after, you might have to settle for active-passive insertion. And if you go with active-active, you're now scaled as to how many firewalls you can put in those active-active clusters. You're also going to be limited on the performance after you've inserted next generation firewalls using basic CSP transits. Why? Because most of the time, if you're trying to get any type of scale, you're going to have to leverage IPsec and BGP to those firewalls. And that lowers your throughput back down to that 1.25 gig per second model. Really limiting. You also have limited visibility. Depending on the insertion model, you now have to leverage SourceNAT. If you leverage SourceNAT to ensure traffic symmetry, because firewalls are stateful boxes and need to make sure that the traffic and the flow is symmetric. Well, you've now lost visibility into that source IP. That is not going to go over well for your security team. Basic CSP transits have very limited health checks into those services that you've inserted, meaning if a firewall goes down, either it's going to take a long time for something to be detected for it to be switched over to another firewall, or you're going to black hole traffic for a period of time. That's not reasonable. Everything to do with service insertion with a basic CSP transit environment is manual. The spin up of the firewalls, the configuration of the firewalls, the insertion from a routing perspective of the firewalls, the lifecycle management of the firewalls, all manual, not scalable, not easy, cumbersome. Lastly, leveraging basic CSP transits for service insertion can be quite complex. It's up to you, like I said, to manage those firewalls, to put them into the path of traffic, to configure routing end to end, to handle the health checking, to configure the IPsec and BGP, and to manage all of that. And as you scale out to multiple pods of firewall networks, you're then in even more trouble. Let's look at Aviatrix. You can insert any next generation firewall in an automated fashion, leveraging the Aviatrix controller. Now, this is not limited to next generation firewalls. You can also insert really any layer 3 service. You want to insert an SSL decryption solution? Go ahead. You want to insert a WAN optimization solution? Go ahead. SD-WAN solution? Go ahead. It's the same model for insertion for any layer 3 service. Aviatrix has thought through the scale problem. We don't have any scale problems with firewall insertion. We can support upwards of 20 firewalls across multiple availability zones per firewall domain, and we ensure that you have high throughput end to end. I'm talking about 70 plus gigabits per second in and out of these firewall clusters. Because Aviatrix is handling the forwarding of traffic to these firewalls, we can handle the hashing for load balancing. We handle the source IP preservation for visibility. You no longer have to leverage source NAT. You no longer lose visibility into who the source IP was. The Aviatrix controller and gateways can handle advanced health checking of these services. So we'll monitor the management or data plane of the service you've inserted. So if it goes down, it's no longer available, it can no longer forward traffic through its data plane, we can quickly remove it out of the path of traffic and insert another healthy service to take on that traffic. Quite seamless, all automated. And what I really love about the Aviatrix platform is that this whole insertion of next generation firewalls or layer 3 services is policy based, it's automated. The whole spin up of those appliances is done for you. The bootstrapping, the programming, the routing, the insertion, and the removal is all handled by the Aviatrix controller and the policies you put in place for your organization. Lastly, it's so incredibly simple and streamlined that your mind will be blown. You can spin up these firewall networks in minutes versus hours or days if you were leveraging basic CSP transits. Because Aviatrix understands how to insert these, how to automate it, all the complexity is done for you. You just click next, 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 drop down this, drop down that, select this, select that, hit go, and it handles it all for you. Who wins this one? You betcha, Aviatrix wins this one. No argument, hands down. One of my favorite features in the Aviatrix networking platform. All right, now we're cooking. Advanced networking, things like NAT, traffic engineering. I love this stuff. This is my background. So let's jump right into it. Basic CSP transits, what do they support? Well, when we're talking about NAT, very basic internet egress NAT or one-to-one NAT. Super straightforward stuff. Very limited equal cost multipath architectures, if any at all, and little to no traffic engineering support. It's very difficult to manipulate routing within the cloud to ensure you're taking the most optimal path based on your architecture. You don't have the tools, the knobs, the functionalities to manipulate your pathing within the cloud. It's a take it or leave it scenario. So let's look at the advanced networking functionality you'll find with Aviatrix. Aviatrix supports destination NAT, source NAT, policy-based NAT, advanced mapping on a per connection basis. Really, you can do NAT in all sorts of ways in the cloud and in all directions. We've sat down with customers with some pretty complex scenarios that we've been able to solve with our NAT solution. And our NAT solution has gotten better with every release because we take feedback from the customers and implement it into our solution. Because you're leveraging the Aviatrix data plane, You can support NAT pretty much anywhere in the cloud, in the transits, in the spokes, on the Aviatrix VPN concentration points, on Aviatrix partner connectivity points, pretty much anywhere. You have these gateways placed strategically across your multi-cloud network where you can leverage NAT functionality. You can now bring that enterprise NAT functionality to any cloud. Aviatrix supports eCMP everywhere. I'm talking about transit to transit, transit to spoke, transit to on-prem, transit to partner. We support eCMP everywhere, and it's toggleable, if that's a word. You can turn it on and off. Aviatrix is continually improving the logic built into our controller's brain. And so we have an advanced best path and backup path logic that is leveraged to ensure you are following the most optimal path to your applications and to on-prem or to other clouds. We support BGP AS path preservation within the cloud and across clouds. We don't just clear it all out the moment we learn BGP routes. No, we carry that AS path end to end so it can be leveraged for best path calculation, for loop prevention, and so on. We can support the prepending of AS paths so you can manipulate traffic in and out of your cloud. We support leveraging BGP metric for best path calculation, BGP summarization, all those tools you need as your architecture gets more complex. We have them to ensure you never run into any bottlenecks or traffic engineering problems in the cloud. So who wins this one? Without a doubt, Aviatrix takes home the gold. Visibility and troubleshooting. Let's jump right into it. Basic CSP transits offer very limited flow information, basically flow logs, which really are just a couple data points, not enough for what an enterprise would expect when it comes to flow information. Can't really leverage this for much, honestly. There's little to no troubleshooting tools in the cloud. You don't have any specific tools built into these CSP transit solutions that can provide you the visibility you need for troubleshooting your data plane or your control plane. There's no dynamic topology for visual troubleshooting, so as your organization grows the cloud network, it gets out of hand. You lose focus, you lose visibility around what your network looks like now. And there's no network performance analytics. The cloud service providers don't provide you any information around how the network is performing. It's not in their best interest to do that. So that leads me to say that basic CSP transits are a black box, and you should always be weary of a black box. Now, let's look at Aviatrix. Aviatrix provides detailed flow reporting and analytics with custom filters and tags. If you haven't heard of Copilot, do a Google search on Copilot. Do a YouTube search on Copilot. Your mind will be blown. Very detailed analytics and reporting is provided by Copilot. It uses NetFlow along with our own functionality around filters and tagging to get even deeper information and context in your cloud network. Aviatrix has a tool called FlightPath, which allows for end-to-end network testing within a region, across regions, and across clouds. FlightPath is an intelligent component of the controller. Since the controller knows of all the constructs and all the security groups and everything in the path of the traffic, it can then test it all independently and give you a report to tell you, hey, here's where your problem lies. There's a route missing, or there's a security group entry missing. Whatever it might be, the controller can use its intelligence and the FlightPath utility to tell you exactly where that traffic is broken. So save your time, save your effort. No longer do you have to have a million windows open, different accounts open, different cloud service provider consoles open, looking at every construct to figure out where a mistake is. Aviatrix will pinpoint it in seconds. Copilot dynamically maps your network in the cloud. So every time anything is added or removed, an instance, a subnet, a VPC, a VNet, a region, a peering, whatever, it will show up on the map and the connectivity will be built for you in that map. So it's a real live troubleshooting tool that you can leverage for visual troubleshooting. You can do ping and traceroute, and in a future release, packet capture and performance testing. Because you have Aviatrix gateways in strategic places across your entire cloud network, you now have a perfect place to do packet captures, trace routes, pings, and other network connectivity tests anywhere in the cloud. Because you're leveraging the Aviatrix transit architecture, we can also provide network latency monitoring for spoke to transit to transit within cloud, within region, cross cloud. We can give you that network latency output to tell you exactly what the real-time latency is. Why is this important to you? Well, when you're trying to troubleshoot an application performance problem, you can quickly rule out the network from a latency perspective by looking at the analytics that the Aviatrix platform is providing. Lastly, when you leverage the Aviatrix data plane, you're building an overlay. And that means we now have visibility into how the underlay is performing. And so we can tell you if your underlay, whether it's within region to on-prem, cross-cloud, whatever, is having an issue, the Aviatrix platform will react appropriately and tell you that, hey, tunnels are flapping, tunnels are down, things are black hole. You need to go and look at your cloud source provider network to figure out what's going on. And one more thing, Aviatrix provides a unified visibility and troubleshooting process across all clouds. You no longer have to figure out how to troubleshoot each cloud separately because they're all different. No, just leverage the Aviatrix built-in platform to do all that troubleshooting for you. Who wins this one? Like always, Aviatrix. Moving on to automation and governance, really important topics for cloud networking. Basic CSP transits do offer support for many automation tools, which is great, but that's kind of the problem too, because now you have a fractured automation model. You're leveraging different tools and different automation mechanisms across different clouds, and it's really hard to put them all together. It's really hard to have that unified model to make life easy for everyone involved with the automation in the cloud. Some CSPs offer governance mechanisms with their basic CSP transits. However, they're complex to configure and monitor and manage. Overall, automation and governance with basic CSP transits is overly complex. Let's look at what Aviatrix is doing to change the game. Number one, Aviatrix is an official Terraform provider. You can find our documentation on HashiCorp's website. We go through rigorous testing to ensure that our Terraform mechanism is built perfectly, that anything you can do in the UI can be done through Terraform. Because you have a centralized controller that's multilingual, you now have a simple and unified automation mechanism where you can just program Terraform against our controller, and our controller will handle all the complexity and all the automation needs to be pushed down to every cloud separately. Built into the UI, you can export anything you've done in there via Terraform. So it's really easy to pick up Terraform and figure it out and run with it at scale. Again, because you're leveraging an intelligent controller, we have guardrails in place. So it's really hard to make a mistake as you go through the UI or as you go through the automation with Terraform. We'll make sure what you're doing is supported and the best practice as you go through the deployment model. The controller even supports role-based access control. So if you want some users to only be able to make changes to certain accounts or subscriptions across your cloud network, or you want them to only be able to do certain things within those subscriptions, that granular, it's supported. Lastly, Aviatrix is continually logging and monitoring what people are doing in the cloud because you're hitting the controller first. The controller is your entry point, and so it can log and monitor everything. Who wins this one? Not even a fair fight, Aviatrix. And last but not least, multi-cloud optionality. And this is a quick one because basic CSP transits obviously don't support multiple clouds. The whole point is to lock you in to their cloud. So you're stuck. You can't use best of breed. All your efforts are doubled or tripled as you try to leverage other clouds. So let's look at Aviatrix. Aviatrix is a multilingual solution. Our controller speaks all clouds. Anything you want to do in one cloud is the same workflow in another cloud. We handle the complexity under the covers to make sure it still works the same as it did in one cloud as it did in another. So we support AWS, Azure, GCP, OCI, and as more clouds enter the market and become important, we will onboard them as well. It's all API driven, so it's really not that hard for us to insert new features and new services and new clouds into the Aviatrix platform. It's quite seamless and beautiful. With Aviatrix, you have one network in any cloud. Man, Aviatrix is the undefeated champion of the world because it just won the multi-cloud optionality requirement as well. So realistically, isn't it a no-brainer? If you were an enterprise cloud network architect and you wanted the best for your business, the best for your network, which one would you pick? Basic limiting CSP transits or the Aviatrix enterprise cloud networking transit architecture? I think we all know the answer here. It's Aviatrix or go home. I want to thank you guys for watching. We'll see you in the next one.